Perfect. Awesome. Great. Yeah, thank you for the introduction. My name is Matthew Perez, and today I'll be presenting this work titled Articulatory Coordination for Speech Motor Tracking in Huntington's Disease. This work was also done with the help of Amrit Romana, Angela Roberts, Noelle Carlozzi, Jennifer Ann Miner, Praveen Dayalu, and Emily Mower Provost at the University of Michigan. So the focus of this work is on Huntington's disease, which is a neurodegenerative disease that impairs motor function and manifests itself in speech. Now, with the future goal of telehealth and remote health monitoring applications, what's needed are intelligent systems to be able to track disease progression remotely. And a critical component to to Huntington's disease severity is being able to track motor symptoms. And currently this is done via in-person clinical assessments. And so the contributions of this work is to be able to predict motor severity automatically in read speech using articulation features. In this work, we show that these features outperform raw acoustic, prosodic, and rhythm-based features, as well as transcript-based features. Now, the data set we used was collected at the University of Michigan and contained 62 subjects, 31 control and 31 with HD. And the target which we are using, which we are predicting, is the total motor score, or TMS. And the total motor score breakdown for the control and HD categories are presented in the table below with the mean and standard deviation. The elicitation task used or read by each participant is the grandfather passage. And in all of our experiments, we downsample the number of control speakers to 7 speakers in order to account for the bias of the very low TMS scores on account of the healthy control speakers and the fact that we only have 7 severe HD speakers in our data set. And so our motivation for using articulatory coordination features stems from clinical literature surrounding HD, which has shown that vocal tract and trunk extremities are linked. And what this motivates is that articulatory features might be a useful biomarker for gauging overall motor severity. And to do this, we investigate the use of vocal tract coordination features, which are computed primarily using auto and cross correlations across the different channels in the acoustic signal. So as an example, if we take this MFCC plot and consider the 0th index and 2nd indexed channels, and we perform a cross correlation across these two different signals, what this produces is a feature vector which represents a subset of the full vocal tract coordination feature set. Now this process is repeated across all pairs of different channels in the acoustic signal. And ultimately this produces a very high dimensional feature vector. Now prior works which have mainly focused on depression have utilized dimensionality reduction either through larger time intervals or eigendecomposition in order to reduce the dimensionality of this data set or of this feature set. However, more current works has also opted to just utilize the full feature set as is. And in this work, we do a combination of both and experiment using eigendecomposition to produce EVTC features, as well as utilizing the full vocal tract coordination feature set, which we call FVTC. Now, our baseline features, which we compare against, are transcript-based features, which are extracted from ASR output, and we utilize the timing information to extract things like speech rate, pauses, pronunciation, and filler usage. We also utilize OpenSmile IS-10, which considers prosodic and rhythm-based features, and this is something that's been commonly used in other disordered speech research, and IS-10 also contains jitter, shimmer, and fundamental frequency, which is more specific to Huntington's disease-related research in work done by Riyad et al. And lastly, our final baseline feature is just utilizing the raw acoustic feature of either MFCC signal or delta MFCC signal. And for all of these baseline features, we apply broad statistics, where we take the mean, standard deviation, min, max, and median over these different feature sets. Now we perform feature preprocessing, which includes normalization and feature selection, where we select the top 75 features based off of the F value, which is computed over the training set. For our classification or regression system, we utilize an elastic net model, where the L1 and L2 regularization terms are weighted equally. And our decision to utilize elastic net stems from its ability to handle multicollinearity and perform variable selection and regularization simultaneously. For each experiment, we perform 100 runs of the experiment, where we select a random 20% of the speakers to be held out as the test set. Now for experiment 1, our goal is to first investigate the effectiveness of VTC in comparison to these other baseline metrics for the task of TMS prediction. Our metrics which we utilize are the root mean squared error, R squared score, the Linz concordance correlation coefficient, or CCC, and we also look at the CCC across different binned HD severities, which are pre-manifest, early stage, and late stage HD. So looking at our baseline features, we can see that the transcript-based features actually perform the best across all of our metrics. However, one important consideration to note here is that these transcript-based features are utilizing the entire grandfather passage. And in our work, we currently segment our data set into 10-second segments. So the rest of the baseline features, as well as VTC features, utilize 10-second segments in order to increase our data set size and increase our sample size. Also, prediction is performed at the speaker level, so predictions for each segment are averaged over across all speakers in order to get a speaker level TMS prediction. So with this in mind, our best feature actually ends up being the raw acoustic delta MFCC feature for our baselines of comparison. Now when looking at how VTC ends up performing, EVTC as well as FVTC, MFCC perform worse than the raw acoustic delta MFCC baseline. But FVTC delta MFCC actually outperforms all the other baselines with regards to these different metrics, and is statistically significant with regards to RMSE and the CCC metric. Now for our second experiment, we look at investigating how segment length affects performance, where the practical consideration of this would be looking at different read passage lengths and seeing how the feature performances are affected by this. So we investigate different segment lengths, where we segment the grandfather passage into 7, 10, 15, 25, 20, and 30-second segments. And here we preserve prediction at the segment level rather than being done at the speaker level. And here you can see it, FVTC, which is in orange, outperforms all of our other baseline features, where for RMSE we see a lower value, and for R squared and CCC we see increasing performances. As the audio segment length increases, we can see performance of these FVTC features also improve, and even surpassing these transcript-based features, which utilize the entire grandfather passage utterance. And in our final experiment, we look at analyzing these FVTC channels by themselves in order to see which channels are most informative with regards to TMS estimation. To do this, we look at the F-value scores, and in the graph, we can see that the red indicates a higher F-value, and thus scores which are more relevant to TMS estimation. And we conclude that the lower channels, or channels 0 through 6, represent sort of the most informative channels for TMS estimation. And this was something that, interestingly, was also corroborated with other HD researchers, such as Rashid Riyad, in other features such as MFCCs and delta MFCCs. So in conclusion, this work looks at investigating VTC for characterizing motor symptomatology in HD speech. We do this by using 10-second intervals where we show that FVTC outperforms other acoustic features, achieving an RMSE of 17.9, an R squared of 0.32, and a CCC of 0.51. We also show that FVTC improves as audio length increases. And we show that this feature set outperforms other baseline features as the audio length increases as well. And lastly, we show that based off of F value, these lower frequency channels are more relevant to TMS than the higher frequency channels of FVTC. So with that, I'd like to say thank you. And we are looking at making the code for extracting these VTC features public on this GitHub page. And if anyone has any outstanding questions, feel free to either drop it in the InterSpeech platform or email me at the email below. Also, myself and Amrit Romana, who's a collaborator, are here in person at Brno, so we'd be happy to talk to you if you are here in person. So, thank you.